So what we're showing here is our traditional Capture Jet hood. Capture Jet uses a small fan that's built into the front of the hood. We take a very small amount of room air and pull it through a pressurized plenum to create a low pressure zone around the perimeter of the hood. It allows us to capture and contain the smoke per UL 710, but also the convective heat generated by the cooking lineup at a lower airflow, typically about 30% less airflow than a standard kitchen hood. We would also, in applications where we have large amounts of CFM and very specific concerns about peak and idle cooking conditions, we can add demand controls to that. That allows us to vary the speed of the exhaust and supply based on the cooking activity under the hood. We'll utilize an infrared index sensor that we sight to the actual equipment and look for temperature fluctuations up or down. I think a great example I use is if you drop a basket of frozen fries in hot oil, that surface temperature actually goes down before it comes up. We detect that and we understand the cooking process has started, and we increase the airflow at that point in time. We do have the first balancing damper in the industry. We listed it back in the late 90s, early 2000s. When we got into the control side, we added an actuator to that damper. So we have a system there. We can put controllers and pressure transducers on board at each hood, as well as dampers with actuators. And you can group multiple hoods to a common exhaust fan and still get true demand control at each individual hood. So if you're only cooking on 2 hoods and 4 hoods are idle, we're only exhausting for 2 hoods. And we've been collecting data for these types of applications since the mid-2000s. So we have curves established for these different segments, and these are real-life examples where I can go into a B&I application, and here's a corporate dining facility that has 3 hoods with a Marvel control system. This is
that's impressive.
This is what they're saving every year.
That's really good.
So we can crunch these numbers ahead of time, but we've got real-life examples for hundreds
really
and hundreds of applications.
It spells it out.
Yep. So this was 3 hoods. This was a larger project here. Let's go back to here. So this was a much larger facility, 12 hoods operating 7 days a week, 17 hours a day. They're saving close to $100,000 a year on energy.
Wow.
So, yeah. So we put this information now. We have a new tool for you guys. It's called a high-value proposal.
Okay.
So a lot of times in the design stage, we are asked to put together budget proposals.
Right.
We still do that, but this is a separate report that talks about the true benefits that we're bringing and the difference between Halton and brand A, B, or C, and the benefits that we're gonna bring to the table and the energy that's going to be saved. Hopefully it aligns with their sustainability approach and shows them the things that they're going to need to know to understand the differences of Halton.
Very good.